so that you can see it. Okay. All right, so I'm just gonna work through these problems. No, I'm not planning on having you turn in this work since I'm doing it with you. I'm assuming you're going to write it down for your own benefit, right? Because you want to do well on the test. Remember, it is an open note test, so these could be considered notes, right? So this might be a good thing to have in front of you. Not that these are going to be the exact questions, because they're not. There'll be some takes on this. There will probably be one or two in there that I kind of try to throw a twist on something we've done, just to make sure that we're not just rote memorizing and just copying right out of our notes, okay? All right, so we are converting to radians on this one. So when we convert to radians, okay, I'm gonna ask a question in the chat. You ready? When I convert to radians, what do I need to multiply by? Tell me in the chat. Show me that you understand this. I see 180 coming up a lot. We know it has something to do with 180. That's good. I'm seeing some pi over 180. That's a little bit better. Okay, so it is, in fact, it's pi over 180 is what we're looking for. So we are going, because we got to get the pi put in, so we're going to multiply by pi over 180. All right, so when I do that, I'm going to try to simplify. You can and will have access to on the problem, and I'll try to put a calculator practice problem in there tomorrow when we do our little practice, so you can see what it looks like. So you'll have access to a calculator. I would put this in my calculator and use the fractions to reduce this, but since I don't have that, I'm going to kind of go old school here. I'm just going to divide by 2. When I divide by 2, I get 191 there and 90 here, and I don't believe that that simplifies any more than that. And it's going to be something crazy, okay? So it's not going to be normal. I'm going to shut a door because my son is being loud. There's like a rap video going in the other room. I don't know what his teacher's having him do right now. Okay, I walked in there yesterday and he was dancing to his math lesson. If only our math lessons were that exciting, right? Okay, you don't want to see me dance. If we go back, I will dance for you in, I do have one dance that I do. I will dance for you in May after the AP test, okay? All right. All right, it's really pathetic, but it's worth looking forward to. All right, so to convert to degrees, we're going to go back the other way. The test is very heavily focused in radians, but I figured we would throw this in there because radians is what we want to do for calc. All right, so I'm going to get rid of my pi's. I am probably going to divide by at least 9, right? 9 goes in here 5 times. 9 goes into 180. I don't know. I have to get my calculator out to do that. 180 divided by 9 is 20. Oh, and what do you know? 5 goes into 20 4 times. And then I got to do 4 times 32, which equals 128 degrees. Because there was still this 32 hanging out there. All right. This is the one and only degree problem. All right. You will want to make sure, and I will try to see if I can find this setting, that the calculator is in degree mode. All right. You may use your graphing calculators, that's fine. But again, I'm going to try to embed a calculator into the test for you. And hopefully we can make sure it's in the right mode. So if you are in the park flying a kite, so we're going to fly a kite. And I think I've got a slight typo in the problem here. We're going to assume you're flying it with your toes because it makes the math easier. Yeah, so here I'm going to say feet. Okay. You have let, good typos, let out 80 feet of kite string. So this is your 80 feet of your kite string. Okay. You estimate the angle of elevation to the kite from your foot. Okay. Is 37 degrees. How high is the kite above the ground? So now we have our right triangle there. So how high is the kite above the ground? We are looking at this value right here. Okay, so I'm going to ask a question in the chat again. Which trig ratio am I going to use to solve that? So tell me in the chat that you understand that. So which trig ratio am I going to use to solve that? Sine, cosine, tangent. I feel like I'm muted right now. No, I'm not muted. It's just slow. Okay. Just slow today. Oh, you know what? I have it scrolled up to the top, so that's why I can't see you guys. I can see it now. All right, I've got about just over half a dozen of you saying that it's sine. Okay, so let's check that out. So we know we have the opposite, and we know we have the hypotenuse, so that is in fact sine. So we're going to do the sine of 37 equals x over 80, and then I'm going to multiply both sides by 80. And when I hit the buttons on my calculator, I got 48.145. And remember, you do need to be accurate to 3 decimal places, okay? Always, even if it doesn't say it, okay? And then we would label this in feet. All right, it's gonna get noisier. Oh, it's Wednesday. The garbage people, I guess if we had the holiday, so garbage will be tomorrow. The gardener just showed up though, so he makes it noisy. All right, we're now into exact value of each trig function. This is going to be there, okay? And tomorrow, once we're done with a little practice test, we'll do a little Kahoot based on this, all right? So we can practice these. So your unit circle is part of your notes. You should have that out. You hopefully built it. I would use the coordinates. You don't have to. You can use the triangles. That's up to you, okay? I'm going to go teach based on the coordinates right now, okay? So I've got the sine of 5 pi over 3. So I'm going to find 5 pi over 3. I know the sine is the y value, so that is negative square root of 3 over 2. Done. I picked one of each type though, right? So we can kind of see a little bit of everything. It says now I want the cosine of pi over 2. I know cosine is the x value, not the y value. So I'm going to go to pi over 2. I'm going to grab the x value, which is 0. So sine and cosine, easy peasy, right? All right, tangent gets a little bit trickier. Tangent, we know we have to have the sine value divided by the cosine value. So the y value divided by the x value. So I'm going to go to pi. I'm going to do the y value divided by the x value, which is 0 divided by -1. And that's okay. It's not undefined because we're not dividing by 0. 0 is on the top, not the bottom. That one is just 0. Okay. Secant of 3 pi over 4. We know secant is the reciprocal of cosine. Okay, so it's like 1 over cosine. So I know whatever value I get, I'm going to flip the reciprocal. So I'm here at 3 pi over 4. And cosine is the x value, so I'm going to flip that value around for my secant. So I'd get -2 over square root of 2. Now, you've seen this question quite a few times in the warm-ups, okay? So I give you a huge list of all the possible answers from the unit circle, right? So we know that the square root of 2 is not going to be on the bottom of any of that. So I'm going to have to rationalize it. So I multiply top and bottom by the square root of 2. So I get -2 square root of 2 over 2, because square root of 2 times square root of 2 is just 2. So I'm going to go ahead and cancel, so I'd end up with negative square root of 2. So, and it will be like that on the test where I give you the huge list of all the possible answers, and you have to pick, okay? Make sure you know what you're picking, and you will not have the same questions as your neighbor, okay? All right. Looking at 7 pi over 6. So cosecant of 7 pi over 6, let's find that on here. 7 pi over 6 is right here. We know cosecant is the reciprocal of sine. So I know I'm going to take the y value for sine and I'm going to flip the reciprocal, which just happens to be -2. All right. The cotangent of 4 pi over 3. So that's cosine divided by sine, or the x value divided by the y value. So 4 pi over 3 is here. My cosine is -1/2. My sine is negative square root of 3 over 2. Now we've got some shortcuts that we're allowed to do on this one. So we know the double negative, first of all, goes positive. Then we know that our denominators, our shortcut, rather than flipping and multiplying all that, is we just cancel the denominators. So I'm down to 1 over square root of 3. Okay. And then I know I'm not allowed to leave that in the denominator, so I need to rationalize it. So we've got square root of 3 over 3. That's probably the worst one, right? Would be one like that if it came up. All right, do we have any questions on the exact value type problems? All right, that's like almost halfway through all the problems right there. Okay. All right, so now I need to find the value of cosine inverse, or what we call arc cosine of 1/2. So only on this one single problem would we be restricted to quadrant 1 and 2 for cosine. Remember, for arc sine and arc tangent, we are restricted to 1 and 4. But that's only when I start with an arc. So we only do this when we start with an arc. When I do the thing where I take the arc sine of both sides, then I have I can do the whole circle. Okay. All right, so arc cosine means I'm going to find the radian measure, so I'm looking for the theta value, when the x value, the x value is positive 1/2 only in quadrant 1 and 2. So I'm going to look in quadrant 1 and 2 here, and I'm looking for positive 1/2. There's positive 1/2, which means my radian measure is pi over 3. It will not be in degrees on the test. Okay, so again, the one part of the circle with the coordinates is the one to use. You can, if you have your calculus book and you open up the front cover, there's a unit circle right there. You could use that. Okay, your trig identities are also on that page. I don't know if you caught that. I don't have a calc book right in here, but I had a notebook page. If you look, oh wait, here, this will have it. Okay, so it's the same as inside this trig book that you had. I don't think I had to online check it out. Some of you checked it out last year. Okay, it looks just like this. It's on the inside front cover. Okay, you have that page. Okay, you may use that on this test. All right, if you notice, it has your reciprocal down this first column right here. Okay, all of your identities that we have talked about so far are right down that column. Okay, so you could have that page open for this test. That's okay. All right. Okay, I can't prevent you, so I might as well just say you can use it, right? All right, so let's look at the next one here. So now we are solving 100%. These are probably next to the exact values. These are the most important problems on the test, okay? You're guaranteed to have a couple of these, all right? So I am looking for the secant of -2. Well, I know secant is not on my unit circle because I have to get it down into just x's and y's. So I am going to flip it to cosine. A lot of you have asked me questions about what I don't understand. I don't have anything in the denominator. Well, you always have 1 in the denominator. So I'm going to put a 1 in the denominator and flip the reciprocal. Okay. I am now going to take the arc cosine of both sides. Okay, so this goes away, and I'm left with the angle of the arc cosine of -1/2. In the instructions, it says, hey, I get to use the entire unit circle this time. So I am going to use the entire unit circle. All right, I'm going to walk around the circle. Because I'm in cosine, I am looking for everywhere where the x value is equal to -1/2. So I'm going to go for my x values. That's positive 1/2. Here's a -1/2, so I'm using 2 pi over 3. I'm going to keep going. I am using 4 pi over 3. And then I'm going to double check. Sometimes it stops at 2, sometimes it doesn't. It looks like we're good. All right. In number 12, we're going to make it act like some algebra. Okay, look, it's all algebra. We're going to make it act like a variable. So make the trig act like a variable. So I'm going to get everything off the variable first. So I'm going to subtract 3 first. And then I'm going to divide by the 3 that's the coefficient in front of tangent. So when I do that, I get -1. Hopefully I'm not going too fast. I know I'm kind of whipping through it today here. All right, so this is the one that's tricky. So I want to actually see if you guys know this. So when I have tangent of -1, and I'm going to arctan both sides, let me do that first. All right, when I go to look for an angle measure in the unit circle, okay, what am I looking for in terms of my sine and my cosine? What kind of values am I looking for? Can you kind of tell me what they would look like in the unit circle? Put that in the chat for me. I'm going to give you a minute to think about it and put it in the chat. So everybody type something in the chat for me. Okay. I'm seeing, oh, I like it. I like what I'm seeing. Okay, I like the one positive, one negative. I'm liking the negative square root of 2 over 2. I'm looking for that same number opposite signs. I really like that, okay? So same number opposite signs is exactly what I'm looking for around my unit circle. So I'm going to do that. So same number, same number, same sign. Can't use that one. I'm going to keep going. Same number opposite sign, so I'm going to get to use square or 3 pi over 4. I'm going to keep going. Same number, same sign. Don't get to use that one. Same number, opposite sign, so I get to use 7 pi over 4. Okay? All right, we're going to do one more here of that kind. So this one, pretty much guarantee you're going to see one like this because I'm going to change that number, or that number in there. We want one that's called a multiple angle. Okay? So I'm going to put a number in front of your, in front of your angle. So the first thing I'm going to do is I'm going to go to my unit circle and I'm going to say, hey, I want to find where the x value is at, because I'm going to arc cosine both sides. So arc, it cancels there. 3 theta equals arc cosine of square root of 3 over 2. So we're looking for where the x values are square root of 3 over 2. So square root of 3 over 2, so I get pi over 6. Notice I'm going to leave some extra space. Positive square root of 3 over 2. And you notice I always travel around that unit circle the same way, so I don't mess it up. When I'm not skipping around, I don't miss anything. And 11 pi over 6. So instead of just setting theta equal to, though, I set this 3 theta equal to it. So there's one tiny little step extra. From there, I either divide by 3 or I am multiplying by 1/3 on both sides. So these are canceled. And then I get theta equals pi over 18 and theta equals 11 pi over 18. And there's a lot of ways I could rearrange this. I could do this same setup here, but make that the multiple angle in there. Okay, so I could kind of test both in one if I wanted to. All right, so just because it looks one way here doesn't mean it might not look slightly different on the test, but you should still be able to solve it. If you practice those 3 and the 3 on the other thing, you'll be fine. All right, we are into simplify, so this is where you need your other identities. Okay, we're going to simplify as much as we possibly can. And again, I'm going to pick a few of these. They might not be exactly like this. I want to see that you're thinking, okay? And that you can think through how to apply these identities. If all else fails, turn it into sines and cosines, right? So I'm seeing sine. I know I can't get simpler than that. Cosecant, I know, is the reciprocal of sine. So I know I can write it as 1 over sine x. And then what do you know? It pops out. These guys cancel. I am just left with 1. Anytime I see things with something squared, I'm going to think my Pythagorean identities. Specifically, I'm looking at this one right here, okay? I see tangent squared, which I guess I could make that equal to tangent squared, okay, and maybe substitute in. I also see secant squared minus 1, which I don't have, but I'm going to try to create that. So I'm going to take this 1 and I'm going to subtract it over to the other side. So for this piece here, I would have that tangent squared theta equals secant squared theta minus 1, which if you notice, these are now identical, which means I can substitute that in for the yellow highlight. So I could put in tangent squared theta. And then this one, I'm just dropping down tangent squared. I don't know why I'm putting a theta. What should I have in there? Should be an x. Because I was in x's, not in thetas. All right, and then I'm just going to multiply those two together. Tangent squared times tangent squared would be tangent to the 4th x. All right. On this next one, the first thing, even before squareds and any of that, is I look and see and I notice, hey, I've got cotangent in this term and cotangent in that term. I should be able to factor this. So I'm going to take out a greatest common factor of cotangent squared x, which means I am left behind with, in this first term, cosine squared x. And in this last term, remember, there's always an invisible 1 in front, minus 1. Now I'm thinking, gee, I've got squareds. I'm looking for some Pythagorean identities. I'm going to look for this pink Pythagorean one here at the top. I guess I could sub in cotangents, but I'm going to see what I can do with this one because that's kind of like similar to what we did in the last problem. I am going to take the sine and subtract it from the other side. So what that looks like is cosine squared theta equal, I'm not subtracting the right thing. I'm supposed to be subtracting cosine over, not sine. So sine squared theta equals 1 minus cosine squared theta. This one's a little bit trickier, okay? Do they look exactly the same right now, with the exception of x and theta? We're not quite there yet, are we? So I know that sine squared theta, I'm going to take out a -1. This is a really good little, it comes up a lot, multiple choice kind of trick. So when I take out a -1, I get -1 plus cosine squared theta. We're not quite there yet. I'm just going to use commutative property and reverse the order. So -1 times cosine squared theta minus 1. I know I'm doing a lot of steps on this one. Normally I wouldn't do this many. And then I'm going to, so I get just that, so they match exactly. I'm going to divide that -1 over, so I have negative sine squared theta equals cosine squared theta minus 1. Now this and that are identical, so I can substitute in the negative sine squared. So the cotangent squared is going to drop down. I'm going to put in the negative sine squared. I'm not using a theta, though. I'm using an x. And I'm going to pause for a second because we're not quite done, but I want you to catch up and get a drink of water. Okay, I want to try to simplify this part here, right? Because I've got that, and this isn't in sines and cosines, but I know it is the same as saying cosine squared over sine squared times negative sine squared x. Those cancel, and I'm left with negative cosine squared x. That would be as simple as that. One was long. I don't know that I would make it quite that challenging. I think I meant it to be something else, and it turned out to be that. So that's a little bit more challenging than I want the test. But a lot of good thinking went on in that one. Okay, we got a couple left here. All right, we get out at 40. Awesome, we're going to make it. And have time for the joke of the day, because I know we're looking forward to that joke of the day. So we've got to find two angles, one positive and one negative. So remember when we are doing coterminal, and this could be a multiple response type problem, okay? So what I would do with this one is we're going to add 2 pi or subtract 2 pi. And remember, we have different worlds. We have the over 4 world where it would be 8 pi over 4. We have the over 6 world, which is 12 pi over 6. We have the over 3 world, which is 6 pi over 3. Not as used as much. We could do the over 2 world like that. Okay. And you might have to add or subtract more than one time. So I'm going to start by adding 2 pi, which is 12 pi over 6 and over 6 world. And that gives me 19 pi over 6. It's possible that's not one of the possibilities. It's possible I have to do it again. All right, so let's see if my arithmetic's good. Is it 31 pi over 6? So both of these could be answers for the positive. And likely there will be one where you have to do it more than one time. Okay. I also have to get a negative one, so I'm going to subtract 12 pi over 6. We've got negative 5 pi over 6. Maybe I have to do it again to get it to match whatever the multiple choices or the multiple responses. So maybe it's negative 17 pi over 6. So those are both also possibilities for that. All right. So we're going to look at these last two here. I'm not going to, we saw a lot of these that worked with like right triangles. So I'm not going to pull the right triangle ones. I want you to be on the unit circle because I want you using that as much as possible. Okay. So we're going to work with our unit circle. And we know that we are at the negative square root of 2 over 2. And I know I'm forced to be in quadrant 2. Okay. So I know that I could arc cosine both sides if I wanted to. Arc cosine, okay? So I know I'm looking for the x value in quadrant 2 that is negative square root of 2 over 2. So it almost narrows it down even better for us. So I know I am really looking at that theta, right? So I'm looking for the cosecant of 3 pi over 4, because that's what they asked us to find in the end. Well, cosecant is the reciprocal of sine, which is the y value. So I'm going to flip the y value for cosecant, and I'm going to multiply by the reciprocal. So square root of 2 over 2. So square root of 2 times square root of 2 over 2. Those cancel. I just get square root of 2. All right. Then we've got cotangent, and we are in quadrant 4, okay? We need to find the sine. So we know that the cotangent, and don't let me mess this up because I think I messed it up in the other class, is cosine divided by sine. So that means that I need, remember there's always a 1 on the bottom. So the cosine needs to be negative square root of 3, and the sine needs to have a 1. And remember, when we build this back up, we have to divide by 2 on all of them, okay? Because that gets us back on the unit circle, meaning that my coordinate should be negative square root of 3 over 2 1/2, or it could be square root of 3 over 2 negative 1/2. So let's look, but we're only allowed to find that in quadrant 4, and then we've got to find the sine. So I'm looking for the square root of 3 over 2. It looks like here, a negative 1/2, so it's more like this one, which means I am looking for the sine of 11 pi over 6, which the sine is the y value, so I know it's negative 1/2. All right. I think that's it, right? That we get into the road? Yes, it is. Okay. So I've got it recorded. I will put it up. I would try this one again. I would try the Google Forms self-checking one again a couple of times before Friday, okay? Because that's your practice for the test. It should have all the thinking that you possibly need for the test embedded into those two, okay? Okay, so Tina, good question. Let me go back there and point that out, okay? I got to reshare because I unshared. Okay, so the reason I wouldn't use 5 pi over 3 on that one, really, really good question. Okay, so 5 pi over 3 has the x value is 1/2, and I know that I needed my x value had to be negative square root of 3 over 2. Does that make sense? Kind of waiting a little bit for a response. Make sure. Okay, good. Glad it makes sense. All right, are there any other questions, comments, concerns about the little bit of review we did today? I know it wasn't the most exciting, and if we had been in class, I would have had you all on whiteboards and we'd been doing it that way instead of you listening to me talk, okay? But you only have to listen to me talk like twice a week, so. So tomorrow we're going to go over and do a little bit of a practice. How do we do a test and notice, okay? And what are the expectations? We're going to practice that a little bit. It'll be super short. And then we're going to do some Kahoot with the unit circle. Okay, so be ready for some unit circle Kahoot. Because, you know, maybe we'll make the Kahoot, although the other class isn't getting that opportunity. I could make the Kahoot worth some bonus maybe towards the test. Would we like it bonus towards the test? We'll all pay attention then, right? All right, so that is all I've got for today. Okay, so if you don't have any other questions, I'm going to let you go. Oh, wait, we need the joke. I'm sorry. Joke of the day. Yes, thank you, Matthew, for reminding me. I almost forgot. Don't let me forget. First period did not get the joke of the day today. We went too long. Okay, here he is. Here he is.
Hey, guys. Which geometry figure is like a runaway parrot? A Pythagorean.
The eyes just kill me.
You know, geometry. No, wait. Geometry and math are just basically the same thing.
He was processing in his brain, I'm sure, what was the difference between geometry and geography, because he's been working on some geography stuff for school. So, all right, joke of the day is done. We have 3 extra minutes. If you have nothing else, you are welcome to go, and I will see you tomorrow, and we'll practice taking a test. Keep working on the trig and make sure you're ready for Friday, okay? Marco Polo, that's
Hi.
Yeah, go ahead, Liliana.
I didn't know how to get into Kahoot.
Kahoot we're not going to do until tomorrow, and you just have to
not
go to
Kahoot. I mean Khan Academy.
Khan Academy?
Yes.
Did you look at the onboarding stuff?
Yeah, but like it's not giving me a class code or anything, and like when I log in, it's my classes from the last year.
Okay, let me go back to Google Classroom here. Let me get into, I'm going to let you present. I'm going to present real quick, okay, so you can see where we're at. Did I turn off? Hold on. Let me make sure I stop recording first.